Hello, welcome to my channel. My name is Pam. Today we're going to do a math video. We are going to learn how to calculate what day a particular date fell on in the week. To do this math, we will be using our 4 times tables and our 7 times tables. So 28, 56, and 84, they all three divide by 4 and 7. And we will be using these three numbers, 28, 56, and 84, as shortcut numbers to make longer division, shorter division, because we're going to be doing a lot of math dividing by 4s and 7s. So there's 365 days in the year, and if we divide it by 28, we get 13 remainder 1. So it's like there's an invisible calendar within our calendar, with 28-day months, 13 of them, and we get a remainder 1, and that's what makes our birthday move up each year. The only exception is during leap year, our birthday will move up 2 days. Now, if the calendar was 364 days and we divide by 28, we would get 13 months with no remainder, which would mean that your birthday would never move up a day each year. So like, for example, if you were born on Saturday, your birthday would always be on Saturday. But because we have a remainder 1 with 365 days in the year, your birthday always moves up a year, but except leap year, it moves up 2 days. Now, for example, October 23rd is 296 days. If we add all the months up from January to October 23rd, we get 296 days, and if we divide that by 7, because there's 7 days in a week, we get 42 weeks, remainder 2. And that remainder 2 is day 2 for October 23rd. Now, who wants to add up all the months and divide by 7 to find out what the day code is? So now I'm going to show you a shortcut way. To figure out the day code, you just divide the date into 7 and the remainder becomes the date code. This is our date code chart. So when you take a date and you divide it by 7, the remainder becomes the date code. So for example, 0s, 7, 14, 21, 28 would be Sundays. 1, 8, 15, 22, 29s would be Mondays, and so on and so on. So that's how you get the day codes. Now this is our month code chart. And to get this month code chart, all they did was add January and February together and divide by 7, and they got a remainder 3. And 3 is the month code for February. And then they add January, February, March together, divide by 7, and they got remainder 3 for March. So these are all our month codes. On the second column is our leap year codes, because we have to add an extra 1 to all the month codes when it's a leap year. This is our century code chart. So if you want to, you can rewind the video back and just snap pictures of the day code chart, the month code chart, and the century code chart so that you can do the math with me. So calculating century codes. There are 25 leap years in 100 years. 100 plus 25 equals 125 divided by 7, and we get 17 remainder 6. Remainder 6 is the century code, so that's how you figure out century codes. The leap years are skipped in centuries that don't divide by 4. So 1700, 1800, 1900 do not begin with a leap year. 1600 and 2000 starts with a leap year because it divides by 4. And so when you figure out years that don't have leap years, you're going to divide by, you're going to take 124. You're going to skip that leap year and take 124 and divide by 7, and then your remainder becomes that century code. Now let's calculate our famous date on the calendar, and that is July 4th, 1776. The month code for July is 6. And you can go get your day code chart if you snapped a picture of that, and you'll see that the month code chart, that is a 6. The day code is 4. The year code, to get the year code, we take 76 minus 56. And the reason why we use 56 is because it divides evenly by 4 and 8. We get a 20, we divide 4 into 20 because we just broke it down to smaller vision, but we got to still figure out how many leap years are in 20. So 20 divided by 4 is 5. We add that back to 20, we get 25, and then we can either divide by 7 or subtract by multiples of 7, and we get a 4. And then our century code is 4. So our equation is 6 plus 4 plus 4 plus 4 equals 18 minus 14 equals 4, which is a Thursday. And 18 is also in the Thursday column as well. So even if you didn't want to subtract 14 from 18, 18 is Thursday. And the reason why I subtract 14 from 18 is because it divides evenly into 7, 14. But that's just to break it down smaller. And here's the proof that July 17th, 76, the 4th fell on a Thursday. Now let's calculate another birthday out. November 20th, 1997. The month code is a 3. The date is 20, but we minus it by 14. You can divide by 7. And your remainder, you'll get a remainder 6, but I like to subtract by multiples of 7. It's just easier that way. So our day code is 6. Our year code, we take 97 minus 84 because 84 divides evenly by 4 and 7. We get a 13. We divide by 4 to see how many leap years is in 13 years. We get a 3. We add that back. 3 plus 13 is 16. Our equation is 3 for the month code plus 6 for the day code plus 16 for the year code equals 25. And then we subtract that by 21 and get a 4. And 25 is also in the Thursday column. So you don't have to reduce it all the way down to 4 if you don't want to. And here's the proof that November 20th, 1997 fell on a Thursday. Now we're going to do another birthday, November 15th, 1943. The month code is a 3. The day code, our date's 15. You can divide by 7 to get 2.1, or you can subtract by 14, since you can divide 7 evenly into 14 and get a remainder 1, or 15 minus 14 is 1. Our year code, we take 43, we subtract by 28, since 7 and 4 divides evenly by 28, we get a 15. We divide by 4 to see how many leap years are in 15. We get a 3. 3 plus 15 is 18, which is also in the Thursday column or the 4 column. And we could reduce that farther down if we want. 18 minus 14 is 4. Our equation is 3 for the month code, 1 for the day code, 4 for the year code, equals 8, and 8 is in the Mondays column, but we could subtract it down from, 8 minus 7 is 1, and 1 is a Monday column. It fell on a Monday, November 15th, 1943. November 15th, 1943 fell on a Monday, and this is the proof right here. Now let's do another birthday. April 29th, 1958. The month code for April is 6. We take the date 29 and subtract from 28. And I believe you already know why we do this, because 4 and 7 divides evenly by, 7 and 4 divides evenly by 28. We get a day code 1. We take the year code, for the year code, we take 58 minus 56, because 4 and 7 divides evenly by 56, so 58 minus 56 is 2. So our month code is 6 plus 1 for the day code plus 2 for the year code is a 9, which falls in the Tuesday column. but we could reduce it farther down by subtracting by 7, and we get a 2. 2 is a Tuesday. So April 29th, 1958 fell on a Tuesday. And here's the proof right here that April 29th, 1958 fell on a Tuesday. Okay, I like to do a birthday with a century code to show you how this works. So the month code for September is 5. Our date is 16, so we're going to either divide by 7 and use the remainder as the day code, or we're going to subtract in multiples of 7. And I like to subtract it in multiples of 7. So 16 minus 14 is 2, so the day code is 2. For the year code, we take 7 and we actually divide by 4, and we get 1 leap year. So 7 plus 1 is 8, and then we add the century code 6 to the year code, and we get a 14. And a 14 is in the Sundays column, but if we were to divide by 7, we would get a remainder 0, which is a Sunday. And then our equation is 14 plus 2 plus 5. So 14 for the year code and century code together, plus 2 for the day code, plus 5 for the month is 21. And 21 is also in the Sundays column. But we could divide that by 7, and our remainder would be 0, which is a Sunday. And here's the proof that September 16th, 2007 fell on a Sunday. So now we're going to guess birthdays. Since I showed you the math in part 1, I want you to do the math and figure out what day of the week was June 29th, 28. Pause the video, figure it out, and then unpause it, and I'll give you the answer. Okay, if you got Saturday, then you did the math correctly. So the month code for June is 4. We take the date 29 and subtract it from 28, because remember I said 7 and 4 divides evenly by 28, and that's our little shortcut. We get a 1 for the day code. Then we take the year 68 and subtract it by 56. Why? Because 56 also divides evenly by 4 and 7, and that's a shortcut. We get a 12, and we divide that by 4 because we broke the division down smaller, but we still have to know how many leap years is in 12. So there's 3 leap years, and we add that back to 12. So 3 plus 12 is 15. And we're going to subtract it from multiples of 7 to get our 1. So our equation is 4 for the month code, 1 for the day code, and 1 for the year code. And it's a 6, so it was on a Saturday. And here's proof that June 29th, 1906 was on a Saturday. Now let's see if you could calculate December 8th, 1995. Pause the video, do the math, and then unpause it, and I'll give you the answer. Okay, if you got Friday, you did the math right. So the month code for December is 5. We take the date 8, subtract it from 7 to get day code 1. We take 95, the year, and subtract it from 84, because remember, 7 and 4 divides evenly by 84, so that's our shortcut. We get 11, we divide that by 4 to find out the leap years in 11. We get a 2, we add it back to 11, we get a 13. We subtract from 7, 13 from 7 to get 6 to make it shorter math. Our equation is 5 for the month code, 1 for the day code, 6 for the year code, and we get a 12. And 12 does fit the Fridays column, but we can make it smaller by subtracting by 7, and we get a 5. And 5 is a Friday. And here's the proof that the birthday, December 8th, 1995, fell on a Friday. Okay, now we have April 29th, 1958. Pause the video, do the math, and see if you get the correct day of the week. And then you can unpause it, and I'll let you know if you got it right or not. So if you got a Tuesday, you got it right. So the month code for April is a 6. We take the date, 29, subtract it from 28. You should know by now why we do this. We get day code 1. We take the year 58 and subtract it from 56 and we get 2 for the year code. Our equation is 6 for the month code, 1 for the day code, and 2 for the year code. We get a 9, and 9 falls into the Tuesday column, and April 29th, 1958 was on a Tuesday. And here's the proof that April 29th, 1958 fell on a Tuesday. Now, what day of the week did October 28th, 1993 fell on? Pause the video, do the math, unpause it, and I'll give you the answer. Okay, if you got Thursday, you got the answer right. The month code for October is 0. Remember I told you there's an O in October. Also in the 10, there's a 0. And of course, 0 and O look the same, so that's one way to remember that October is a 0 code. The day code, we subtract 28 from 28 to get a 0 day code. You should know why we use 28. We take the year 93, subtract it from 84. Again, you should know why we subtract 84 from 93. We get a 9. We divide 4 into 9 and get a 2, and we add that back to 9 and get 11. Our equation is 0 for the month code, 0 for the day code, 11 for the year code, or you could subtract it from 7 to get a 4 for the year code. And Thursday, October 28th, 1993 fell on a Thursday. And this birthday actually zeroes itself out to where you're left with the year. And all you really need to know with this birthday is the year code, and that's what makes a birthday for this particular birthday. And here's the proof that October 1993, the 28th fell on a Thursday. Okay, let's guess another birthday, December 10th, 1962. Pause the video, do the math, and unpause it, and I'll give you the answer. Okay, if you got a Monday, you got it correct. The month code for December is a 5. We take the date 10, subtract it from 7 to get day code 3. We take the year 62, subtract it from 56 to get a 6. We add 1 leap year to 6 to get a 7, and this year zeroes itself out. Our equation is 5 for the month code, 3 for the day code, 0 for the year code. We get an 8, and 8 falls in the Monday column. And here's the proof that December 10th, 1962 fell on a Monday. This is our shortcut way of figuring out a year code. So June 29th, 1968, the month code was a 4. We take the 29th, the day, subtract it from 28 to get day code 1. We add the month code 4 plus 1 for the day code is 5, and that's our birthday code. So all you gotta do for June 29th is memorize 5, and if you know the year code, you'll know when the birthday is each year. So we take the birthday falls on a Saturday, and the day code for Saturday is 6. So we take 6 minus 5, and we get a 1, and the year code is a 1. Now that we know that the year code is a 1, we can calculate any birthday in 1968. So September 16th, 1968, the month code was a 5. The day code, we take 16 minus 14, and we get a 2. And actually, if we add 2 and 5 together, our birthday code is a 7, but we can just divide it by 7, and the birthday code becomes a 0. But the equation is 5 for the month code, 2 for the day code, plus 1 for the year code is 8, and 8 is in the Mondays column. And here's proof that September 16th, 1968 was on a Monday. Now I have October 23rd, 1968. We already know the year code is a 1, so this is easy. The month code for October is 0. We take the date 23, subtract it by 21, we get day code 2. And because there's a 0 month code, the day code is a 2, and so is the birthday code. The year code is a 1, so the equation is 1 plus 2 is 3, and 3 is a Wednesday. And here's proof that October 23rd, 1968 fell on a Wednesday. Now, I'm going to teach you how to calculate a birthday by a person's age. So October 28th, 2024, the person's birthday is on Monday and they are 31 years old. So what we do is we take 31 minus 28. Why do we use 28? Because it divides by 7 and 4. We get a 3, but we still got to divide that leap year. How many leap years is in 3? It's 1, so we get a 4. And then we take the day code 8, because 8 represents Monday. It's in the Mondays column. Monday is day code 8, and we subtract that by 4, and we get a 4, which is a Thursday. So the person was born on a Thursday. And here's the proof that October 28th, 1993 was on a Thursday. And I'll show you the proof that their birthday is on a Monday. So that's even easier than worrying about month codes and date codes and year codes and all that stuff. Now we have December 8th, 2024, and that birthday is on a Sunday. Okay, so their age is 29, so we take 29 minus 28 and we get a 1, and then we add 1 for the leap year, we get a 2, and then we take 7, which is the day code for Sunday, and we subtract it from 2 and we get a 5, which would mean the person was born on a Friday. So this is the current birthday, which is a Sunday, and 7 represents day code. 7 is the day code for Sunday. And here's proof that they were born on a Friday in 1995. Now, I like to share with you that the calendar does repeat itself every so many years. So every 28 years, 56 years, and 84 years, it repeats itself. So you can see that June 29th, 1968 was on a Saturday. 28 years later, it's still on a Saturday. 56 years later, it's still on a Saturday, June 29th. It's on a Saturday in 2020. 84 years later, June 29th is still on a Saturday. Here's another birthday. Our birthdays repeat every 28 years. So October 23rd, 1965 is on a Saturday. In 1993, it falls back on a Saturday, October 23rd. 56 years later, from October 23rd, 1965, it falls back on a Saturday. And 84 years later, from 1965, it falls on a Saturday. Now, I'd like to share with you that we have twin months. In leap years, January, April, and July are twin months. And you can look at and see how the calendars are very identical to each other. You can see how April and July are very identical to each other. And January also is identical to these months. When there are no leap years, January and October are twins. So for example, if you want to know when Halloween is, and it's the month of January, you just got done celebrating the new year, you can look at January 31st and know that Halloween will be on a Tuesday. Okay, March and November are twins. They line up on the same days, other than November is 1 day shorter. February, I don't have it up here, but it also lines up with these 2 months, is 2 days shorter. September and December also are months that start on the same days. So say it's September and you want to know when Christmas is, you can look at the September calendar and know that Christmas will be on a Monday. I want to thank everybody for watching my video.